to summarize, I want to prove this theorem up at the top. I'll let you read it. And I'm only working on the green part of this theorem up here. I just want to prove that this bit here is less than epsilon over 3, and I'm doing that right now. So what I've done is I've shown that there exists, maybe I'll write this in green. I've shown for this proof that there exists, I want to do this in green, I said. There exists an n1 such that for all m and n bigger than or equal to n1, I get this kind of whole hubbub. And it boils down to, if I can erase a bunch of stuff, I'm going to erase all of this to buy myself some room. Just kidding. Okay, fun to watch me erase. So here's what I had on the last slide. It boils down to, I need to get my pencil back. So organized. There exists an n1 such that for all m and n, if you do some algebra to rearrange it, you get mn of x minus fm of c minus fn of x minus fn of c over x minus c, absolute value is less than epsilon over 3. Basically, to get this, we use the mean value theorem on fm minus fn, and then we got that basically f prime m of alpha minus f prime n of alpha is less than epsilon over 3. The mean value theorem says that those prime things are equal to this. And now what I'm going to do is, what color haven't I used? This kind of lavenderish color, I think. I'm going to just look at this thing. Right? Oh, by the way, also temporarily x is fixed, c is definitely fixed. And what I'm going to do is I'm going to fix n as well. So recall c, x belonging to a, b are fixed for this argument. Also, fix n and let m go to infinity. What happens then, and we're going to consider the sequence fm of x minus fm of c, which is just a number sequence, right? X is fixed, c is fixed. You can actually just compute this. This is just a sequence of numbers. Then what do we know? We basically get that this whole thing becomes, right, let's just call this a sub m, since it's just some sort of number sequence. What this is a sub m minus n is fixed, x is fixed, c is fixed. This is just a constant. X minus c are both fixed, so this is just b. This is less than or equal to epsilon over 3. So, which means that a sub m minus a over b has to be between epsilon over 3 and negative epsilon over 3. But now notice, if you just subtract a constant and divide by a constant, the order limit theorem says that that's not going to affect what happens here. What happens here, as m goes to infinity, you're always still going to be less than or equal to epsilon over 3. You're also going to be less than or equal to negative epsilon over 3. So this goes to, this implies that if this goes to a, you get a minus the capital A over b is between negative epsilon over 3 and epsilon over 3. So what are we actually talking about here? The a is the limit of these things, and these things are going to get ahead to f of x minus f of c, which is exactly what we need in here. So we really get the f of x, f of c over x minus c minus the n's like that. This is all going to be true as long as n1 is bigger than or equal to n.